Here are at example 3 from the 1.2 set of notes. We're asked to evaluate this following limit. The limit as x approaches 2 of this particular rational function. Now there's several ways that you can go ahead and proceed with this one. But I think to kind of reinforce those ideas that we can use algebraic techniques, we're going to go ahead and factor the top. So we end up with x plus 2 times x minus 2. And on the bottom, we end up with x minus 2. Now, as you guys can see, we have an x minus 2 on top, 1 on bottom. Those will actually end up dropping out. And so, because something cancels like that, we should then see a hole. Again, you're just setting things up to figure out where is that hole. And so you just do that by setting this not equal to 0, that bottom. Solving for that, we end up with x is not equal to positive 2. So now going ahead and taking this x value, throwing it into your simplified version of the function, you should end up with a y value of 4. So then there should really be a hole at 2, 4. Now we end up with the simplified version of the expression or kind of function. So it comes out to be a line starting with a y-intercept of 2, a slope of 1, and we set at 2 we have a hole with that y value 4. So we should see something that looks like this. And if we go ahead and take out the graphing calculator, let's just go ahead and kind of confirm that. So in our graphing calculator, we're going to start out by opening up a parentheses. Then we have x squared minus 4 divided by another set of parentheses, x minus 2, close parentheses. Going ahead and graphing this, we do in fact end up with that kind of straight line. However, notice there is no hole in this graph. Well, the reason for that is because there in fact actually is a hole, but the pixel density for your graphing calculator can only show so much, but believe me, there is in fact one there. Again, your graphing calculator is just not showing it though. Now, one way that we can kind of go ahead and confirm this is if we go over to our table. So we're going to go over to second table. And you can even in fact see that there is this error happening at 2 because of that undefined statement. Let's go ahead now and even look at a table that's a little bit more, I guess, focused in on what's going around at this specific x value 2. Because we can see that it jumps from like 3 to 5 to 6, and we know that it's 4 algebraically. But I'd really like to go ahead and talk about the limit and what's happening there as you approach, or as x approaches 2. I'm going to go ahead and hit second table set. We're going to start this thing off really, really close to 2. So I'm going to say that it's starting out at 1.99, we'll go with 5. So pretty close to 2. And we're going to go up by 0.001 every single time. Okay? So we're going up really, really small to get closer and closer to 2. Now if I go ahead and hit second table, let's see our table. Here we started at 1.995. Well, that gave us a y value really close to 4. Getting even closer, we end up with 1.996. Getting also really closer to 4. Notice, in fact, all of these actually end up matching because, again, we have that kind of linear function. At least the decimal parts do. But then again, at 2, we see that error because of the undefined. So, in just going ahead now, you can fill out this in your table where we have, this would be considered your left side. This like 1.996 all the way until 2. All the way until 1.999. And then this would be considered to be your right side. okay, because you're just a little bit past 2. But the idea is, as you approach 2 from the left, in other words, if we go back to the graph, in fact, let's use ours. As you approach 2 from the left, we notice that we're getting really close to that value 4. And as you approach 2 from the right, you're getting really close to that value of 4 as well. Okay? And that's exactly then why we say that the limit as x approaches 2 of this particular expression comes out to be 4. So our answer is this limit is 4. And so there you can actually end up seeing our tables talking about the left and right side. Again, just a little bit more, so it's a little more clear for your notes. So again, that is example 3 from the 1.2 set of notes.